So before I go further on that question, organic matter. How does organic matter affect? Is high OM a good thing or a bad thing with your product?
It's just good in general for the plants to have good organic matter. If you have very sandy soils with very little organic matter, the problem with low organic matter is, again, the microbial populations will tend to be sparse, and because they need certain things to survive, and part of that's organic matter that they're using for food and breaking down. And so if you don't have organic matter in the soil, then that microbial population will be low. And it's going to be more challenging for the plants to get the nutrients they need unless you're literally spoon feeding the plants directly with fertilizer, that kind of thing. So it doesn't really affect how our technology works in terms of boosting the photosynthesis in the plant, but it does obviously affect the overall plant production, just as a matter of course.
And the reason I went down that rabbit hole was just was if you water in a sandy soil, you're going to lose a lot of that water really quickly. Whereas if you have a high organic matter, that organic matter is going to hold that stuff like a sponge, and therefore give the plant a longer time to pull the signal out of it. Is that a correct assumption?
Yeah. We have seen evidence that our system does improve water retention in sandy soils. So I'm not sure exactly why that is, unless it's just, I think there are signals in our system that actually improves soil structure to help maybe some of that sandy soil retain some more of that moisture. Exactly how that works or why that works, again, I don't know all the physics behind it, but that's been my observation when I look at some of the reports.
Very interesting, because the reason I went down that rabbit hole is because in the process that I do, I take compost and I strip it to get all of the things that I want. So that's the microorganisms, the humic folic acids, and all of the micro, what we call remineralized material out of it. And then through the next process, I call it, climatic dewatering. So I use vibration to shake the water out of the matrix. And I've noticed that when I find the sweet spot in the vibration, just like we saw on the sand in the beginning, the water falls out of the material. So if I'm on a higher vibration or a lower vibration, it tends to drip. But when I get to that, that resonance, it just drops out. And so in my early experiments, I was brought in to deal with engineered soil systems. So engineered soil systems are 99% sand, 1% organic. And the reason why is because it's very important for them to maintain their structural effectiveness. So it'd be like walking on a putting green and sinking. Your feet sink. No, that's not going to work. A playing field, a sports field where your cleats sink as you turn, you're going to have a lot of leg injuries, et cetera, et cetera. So the work that was being done in a lot of places was because the town, city, state, government, whoever, required that this field to be managed organically and not allow synthetic fertilizers for whatever reason. So in the early work, we could not get protozoa or fungi, or the gentleman that hired me could not get protozoa or fungi to take hold in these low OM soils. And so Dr. Leighton told him, hey, see Leighton up at April's greenhouse. He's doing some work that I think is going to solve your problem. So Sotillo came up, we looked at, microscope my shit, and was like, oh my God, how did you get this? What is this? And I said, well, it's basically kind of like biological mayonnaise, for lack of better words. I've noticed that it really sticks to things. And I created applying this stuff to sand, pure sand, no oil. And it turns the top, 6-8 inches into what I want to call chocolate sand. And I go, once that happens, then we see the ability for fungi to come in and start to set up and create aggregates without destroying the structural property of the sand. Once the aggregates are created, then the protozoa can take hold and begin the nutrient cycling system. So I didn't understand why it did that, why it bonded the sand and allowed for aggregates in a sandy soil. But it was later on in life, probably only 5 or 6 years ago, that I realized, fuck, it's the kymatics, it's the vibration that's forcing these things to bond together that allows for that next step. So that's why I asked that question, is because in my brain, my hypothesis was that, yeah, through what you're doing, it would turn a sandy soil, or give sandy soil the ability to aggregate without ORAD. So that's really cool.
I think that's probably true. Again, when I asked Fulvio, the inventor, I said, "So what's the deal here?" Because originally we thought that we had certain frequencies within our system that directly boost microbial activity in soil. That we were actually boosting the reproduction and the function of microbes in the soil directly with our frequencies. And he said, no, it's more like we're improving the soil structure to give them a better environment to survive. And then obviously by boosting photosynthesis, you create more of an exudase that feeds the microbes from the plant, and keeps them fed so that they start to wake up and they start to do their activity the way they're supposed to.
And also, you're building the cell's ability to create biofilm, and that biofilm is actually what's bonding those particles, or assisting in managing the bonded particles. So when you add biofilm to two particles, now they're glue. So long term, it's more less susceptible to damage, so to say, and that would make total sense. And that's kind of where I wanted to go next. Is that is this a biological food too? Are you stimulating something else in the biology, or is that something too far down the rabbit hole?
You mean soil biology?
Yes.
Yeah, like I said, my understanding now, from after I was corrected by the inventor, was that we are not directly stimulating the microbial functions of the soil microbes. What we're doing is improving the soil structure from a climatic standpoint, as well as improving the photosynthesis efficiency, which causes the plant to generate enough sugar that they can actually donate more of that to the soil microbial population, which is part of the natural process, right? The plants are feeding the microbes so that the microbes can go out and find the nutrients that plant needs in the soil and become that symbiotic relationship, right? When you over fertilize the plant and it gets everything that it needs because we're fertilizing it, we're artificially providing that, and we're increasing the electrical conductivity of the soil and the salinity of the soil, which makes the microbes more dormant. The microbes, all of a sudden, they're deprived of their natural function, right? So now they go into dormancy, or they even die, and then you have a dead soil, essentially. Where if you use an organic natural fertilizer with our technology, we're boosting the plant's natural photosynthesis and keeping that natural ecosystem, that symbiotic relationship with the microbes and the plants going.
Have you ever tested that theory, like that you're definitely not affecting the microbes? Like, have you ever taken the system in a natural system, something that's never been fertilized, right, and test and control and view the soil ecology after a period of time?
We haven't done that. I mean, we've done microbial tests on certain farms. We've done it. We haven't done that in an unfertilized natural environment, at least not to my knowledge. Maybe Mr. Bamelli has. I don't know, but it'd be very interesting to run that experiment.
Yeah,
sure.
Yeah, it would, and I would please ask you to talk to him about just that, because in my mind, I believe that it perhaps isn't directly adding advantage to the microbe, but the other half of me says it would have to. By increasing the kymatics of a cell, you would tend to think that you put it in a better position for its function as well, right? But again, the only way to really test that would be to do side-by-side test and control in a system, a natural system, whether it's a landscape or anything that's just not being fertilized, something that was forest or meadow. But that would be a really, really interesting experiment.
Yeah, that'd be interesting.